We're here on day 4. We'll just be continuing where we left off yesterday. So I'm Laura. I'm back here to walk you through the rest of chapter 3 today. I've got Sienna here. She's going to be helping out with Q&A. So if you have any questions as we go, or if you have any trouble with any of the exercises, just let us know and we're happy to help you out as we go. I see there are still some people still joining the webinar, so we'll start a little bit slowly today. So yesterday, it left off at the end of exercise 3.1. So we're looking at the basics of self-serve with FME Server. So by the end of the exercise, we had created a workspace that reads and writes some raster data, and then we published that workspace up to server using the data download service. So by the end of the exercise, you probably would have run your workspace and seen an output similar to this. So it's very similar to what we've been seeing when we've been running our workspaces with the job submitter service, with the key difference being that we have this data download URL this time, which lets us download a zip file of the output from the workspace. So what we're going to do next is we're going to look at one of the other services within FME Server just to see what that one does as well. And then we'll run through some exercises looking at different key parameter types that we'd be using when creating self-serve systems for our end users. So I guess just before we get going, do we have any questions from anything that we covered yesterday? Does anyone need a little bit more information about anything? I'll just give you a little bit of time. I still see some people are logging in here, so I'll just let them get into their systems. I'm also going to send out the link to our current location in our book. So you're going to be picking up right after exercise 3.1. So I'll just send that out through the chat. So just in case you've lost your place, I've just sent out the link to our current spot in the training manual. Okay. So let's get going. So we're going to be looking at the data streaming service. So this is another very commonly used one within FME Server. It works in a very similar way to the data download service. You'll see when you're publishing your workspace, you'll have the option to register with data streaming. It'll have a set of properties in there that let you set up which writer you'd like to include in the data stream and everything like that. So the key difference here, just looking at all the services that we've covered so far, so the first service we looked at was the job submitter service. That one simply runs the workspace exactly as it is. So it'll read the source data and write it out to whatever location you specified inside your workspace. This one's particularly useful if you're working with, if you're dealing with workspaces that write out to databases. So these would be workspaces that don't actually create files. They simply update a database somewhere. So really wouldn't make sense to be able to download the database itself. There would be nothing to download there. So that's a good example of when the job submitter service is useful. It's also useful if you want to be writing your data into a location within resources in FME Server, as we've seen with some of the other exercises before. The next service is data downloads, as we've seen. What that does is instead of writing the output file to the location specified in the workspace, it will write that into a different location within FME Server, and we'll put it into a zip file and then return a link to be able to download that within your browser. So this type of service will always override the output location of any writer that you specified when you were registering your workspace with that service. The data streaming service is very similar. The key difference here is instead of taking that file and putting it into a zip file that you could then download, it actually takes the file and streams it directly back to the client. So for example, if you have a workspace that created, you see an HTML page, and you ran the workspace in a web browser, you would run the workspace, and instead of getting a summary like this saying what happened, you would actually just get that web page opened directly in your web browser. So you would take that output data set and push it to the client. So you would see this with other data types as well. So if you're writing out to something like a PDF, you would see that open within your browser as well, anything like that. So with data streaming, there are certain types of data formats that make more sense for working with this particular service. So some that really don't make sense would be things that create multiple files in the output. So one example would be something like the Esri shape file. That one, it has the .shp extension for one of the files, but then it has a whole set of sidecar files with additional information. So you wouldn't be able to stream that because you'd actually be getting 5 to 7 different files back. So if you ran that with the data streaming service, you would actually get a zip file back instead, just to deal with all of those different files. So if you want your data to be streamed directly back to the client, you'd want to write out to something that writes out a single file. And you'd also want to write out to something that the client that would be calling the workspace would be able to understand. So in the case of a web browser, so if you're running it directly in Chrome or Internet Explorer or something like that, some formats that would make the most sense would be things like HTML, PDF, PNG, JPEGs. These are all files that your web browser would be able to understand and open and display. So Mime Types. So this is basically a header that tells the client that's receiving the data that's being streamed what type of file is being streamed to it. So you'd see something like this. It'd be content type equals whatever the type of file it is. So in this case, this is for a text file. When you're creating workspaces that you'd be registering with the data streaming service, it's important to set the MIME type correctly so that the client knows exactly what it's going to be getting. For most writers in FME, so if you were to say add in an HTML writer, for example, that writer only ever creates HTML files, so it'll automatically set the MIME type for you. So in most cases, you don't have to worry about it, but in some cases you might. So if you, for example, you were writing out to, say, a plain text file or an XML or JSON file within your workspace, you'd be making use of our text file writer. And in that case, you'd need to set the MIME type to tell FME exactly what kind of data is going to be streamed so it knows what to tell the client, so it knows what to do with it. So something to keep in mind as you're building up your workspaces. The majority of the time, you don't have to worry about that, but if you do see this server parameter MIME type option, you do want to make sure you set that to something appropriate for the kind of data you're working with. Another service we'll briefly discuss here, we're not going to do an exercise on it just because it is a very specific one, but it's an interesting one and it relates closely to the data streaming service. So this one's the Kml Network Link service. So this is a very specific service that really only works with the KML writer in FME. What this one does is it creates a Kml Network Link, which basically is a file that you can open in something like Google Earth. And it contains kind of a bookmark or a network link, as they're called in these files, that will point to the URL for the data streaming service for the same workspace. So it's kind of a weird one, but you basically create a KML file, and then let me open this a bit bigger here. Inside that KML file, you'd see this network link, and that would point to the data streaming service for the same workspace. So when you open this KML file directly in Google Earth, it will actually go to FME Server, run the workspace itself, and then stream the output straight back into Google Earth. So what's interesting with this one is you could set this up to automatically refresh on a certain interval. So if you're dealing with sort of real-time data and you want to be tracking, as one example would be GPS data, if you're pulling in information from a fleet of vehicles within a city or something like that, you could have a workspace that connects to that stream, pulls in the data and writes it out to KML, and then you can create a KML network link that will then automatically refresh that data, say every 15 seconds or however often makes sense, and then it would pull in the latest information and automatically show that inside Google Earth. So you can kind of get an almost real-time view of the data. So it's an interesting one for a display of information. We do have an example on our FME Server Playground that shows a KML network link in action. So if you are curious about exactly how that works, you can definitely check that out. So with that, let's get into our next exercise here. So for this one, it's a very simple exercise, and we're just going to be looking at the data streaming service just to see how that one works. So in our case, we're going to be using exactly the same workspace as we had created for exercise 1. And we're simply going to register it with the data streaming service to see the difference in what happens. So in our case, we've got users who've run the data download version and they like it, but typically when they do run it, all they do want to do is take a look at the JPEG. They don't really need to download a copy of the file for themselves. So we're going to create a data streaming service where they can simply view the data and not need to download it. So let's begin with our first workspace. So if you still have the workspace from yesterday open in Workbench, you can open that up. If needed, you can open up the starting workspace as shown here. So that's in the server authoring folder in FME Data 2019. So I'll give you all about a few seconds to get that open if you need to. I have the workspace open in Workbench already, but if needed, the starting workspace is right here. I think in this workspace, in this example actually, the starting and ending workspace are pretty much identical, so it really doesn't matter which one you download either. Okay, so once you have that open, let me just resize my window here. We're simply going to publish this up to FME Server again, and we're going to register with the data streaming service. So I'm going to go to File and Publish to FME Server. We'll select our connection. We'll leave everything exactly as it was before, so make sure you're uploading your data file as you go. You can even give the workspace the same name as before, it doesn't matter in this case. If it asks you if it already exists and you want to update, we can say yes, that's completely fine. And then in the final dialog when we register services, we can check the box for the data streaming service. For this, it doesn't matter if you have data download and job submitter selected, so you can uncheck those or leave them. It doesn't matter in this case. While we're here, we can take a look at the properties for the data streaming service. So I'm just going to click on the Edit button on the right-hand side. We don't need to change anything, but we can see what this looks like. For the Include Writers in Stream, we'll make sure we have our JPEG writer selected. Once you're ready, you can click on Publish to publish this to server. Okay, so once you've got that published, we can go into FME Server now. So I'll give you a second. If you need to reopen that in your browser, we're at localhost. I'll start from the home page. So just go to localhost in your web browser and we'll log in with the usual credentials, admin, admin. I'm going to do the Run Workspace page now. And then locate the workspace you just published. Hopefully you remember what it was called. So I called mine Exercise 1 Complete. And then under Service, so depending on which services you selected when publishing, you'll see a list here. So I've got the 3 that I selected when I was publishing. I can click on my data streaming service this time. So make sure you've selected that. Oop, there we are. So our service is data streaming. There's no other changes we need to make here, so just make sure your data set is filled in like this. We don't need to set it ourselves. When you're ready, click on Run at the bottom. And you should see the output will look like this. So you notice instead of the usual page that says job ID, whatever, successfully submitted and written 1 feature, it just sends you the data straight back to your browser. Since we're writing out to a JPEG file, our web browser knew what to do with that and opened it up straight away for us. Okay, so just do a quick show of hands. Was everyone able to successfully stream that data to their web browser? Okay, I'll do one more show of hands. Does anyone need a few more minutes with that exercise? Okay, great. So for anyone who didn't raise their hands, if you did see any trouble or if you got any error messages, just let us know through the questions panel and we can help you out with that. All right, so let's move on then. So we've seen the differences between the data download and the data streaming services now. So what we're going to do is we're going to look at more options for creating self-serve systems. So for the next couple of exercises, we'll be working primarily with the data download service. So one key thing when it comes to setting up self-serve services with FME Server, well, a lot of S's in that, is the ability to create parameters so that your end users have control over exactly what kind of data they're going to be downloading. So parameters are items that can help you control various aspects of the FME translations and transformations. So within a single workspace, you can set quite a variety of different types of parameters. So there's a bit of a hierarchy in the parameters themselves. So at the top level, you have workspace level parameters that would affect how everything inside the workspace runs. Below that, we have reader and writer specific parameters that would control everything about a particular reader or a particular writer within the workspace. We also have feature type parameters, which would handle anything related to the feature types on the readers or the writers. Then we even have feature level parameters, which would be set on each individual feature that's going through your workspace. So pretty much all of these parameters could be made available or are set by the author of a workspace. So you'd be setting those within your workspace as you're creating it. Any parameters that you can set as an author, you could also choose to publish those so that your user has access to set those values as well. So for the most case as an author, you'd be setting most of the parameters within your workspaces, so you're the one who knows exactly what needs to happen. But there are some cases where you want your users to have some control and to make some decisions for themselves. So with those, we call those types of parameters user parameters. So you could create a user parameter from any parameter within your workspaces. So I'll be doing an example to show you this if this is a little bit unclear, but basically any parameter value you can set in a workspace can be published, so you can let your end user set a value for it. For self-serve systems, some of the most commonly used published parameter types would be options to set, say, the coordinate system that the data is delivered in. So if your end users care about what coordinate system and projection the data is in the end, you can publish that and give them the option to set that. Another common one is the feature types or layers to deliver. And this is very common, especially in a data download situation. You want to give your users the ability to select what information they're interested in downloading. Another good one is geographic area. So you can let your users decide what area that they're interested in getting data from. So that's done in a variety of ways, and we'll look at some of the options coming up. And then basically any other reader, writer, or transformer parameters. So sometimes users have specific needs and you want to make sure that they're able to set up the workspace in a way that lets them get the data they need. So we'll just look at published parameters themselves. So here's an example of what they look like inside Workbench. So this is a screenshot of the navigator window, and you can see all of the different parameter types that are available inside the workspace. So at the top level here, we've got some reader-specific parameters, so things like the input data set. Down below, we've got the writer-specific parameters. So this would be where the output's going, You see we've got a coordinate system option here as well, so you can set what coordinate system the output data will be in. And here we've got some writer-specific parameters. So these are certain things that would be configurable based on the type of data you're creating. So in this case, this is map info tab. So they've got some very specific things that your users may or may not care about. So something like the file version, if you know they might be using different versions of the software, you can set it up so they can choose what type of version they'd like. Here we've got some feature type parameters. So these are kind of one level lower and specific to the particular layer that you're writing out to. Underneath, we've got the list of different transformers in the workspace, and you can expand any of those to see all of the different parameters that you can set within those transformers. Oops. And then down here, you can see the list of user parameters. So what you can publish any one of these parameters with the green cogwheels, and you'll see it turns pink, indicating that it will be a user parameter that your end user would be able to set for themselves. In order to do that, you would want to right-click on any of the parameters from the navigator window, and you'll have this option to create a user parameter from that. When you set that up, you'll have the ability to set up the type of parameter you'd like to create and configure it with particular values depending on the type of parameter and what options you want to give to your end users. So in this example here, they've created a choice type parameter with two options for the type of area they're working with, if they want a plain area or a sloped area. When they publish the workspace to server, they'll end up with a published parameter with those two options inside of it. So someone could decide what type of area they want to deal with when they run the workspace. So look at a couple key parameter types here. So there are lots of different types of published parameters within Workbench, and we'll take a look at those in the exercise coming up. But a few that are worth highlighting are the choice with alias parameter. So this one lets you create a choice type parameter. So when a user runs the workspace, they'll get a drop-down list of options. What's nice with this one is you can set a display name for those values as well. So in this example, this one's working with a label size. So within Workbench, it expects to get a numeric value for the label size that you're creating. And that value could be anywhere from 1 to 5 in this case. Behind the scenes, FME understands that the numeric value is set in ground units for the data type that you're working with. So it all depends on the coordinate system that you're handling. But for the end user, they don't necessarily know what 1 to 5 means in this case. So it could be 1 centimeter, could be 1 meter, could be 1 millimeter. They really don't know. So what you can do is create these display names to give them more information so they can make a better decision on what they're going to be doing. So in this case, they're 1 centimeter, or they're measured in centimeters. So you can say there'll be 1 to 5 centimeter labels instead of just mysterious numeric values. Another parameter type that we won't be looking at in this training, but is worth highlighting just to mention that it exists as an option, are scripted parameters. So you do have the ability to create parameters that use Python or TCL scripts. I think Python's the more popular programming language to use, or scripting language to use in most of these cases. But if you do need to kind of do calculations within your parameters, one example might be if you're dealing with scaling labels. So if somebody says they want 1 centimeter labels, but your data set's in lat long, what is 1 centimeter in lat long speak? You might want to do the conversion to set the correct number behind the scenes. So you can do that using these types of scripted parameters. So you can do a lot of advanced things if you want to create a Python script and have that do additional work as part of the parameter and send a value into the workspace behind the scenes. So let's get on to another exercise. So I think for most of this chapter, we'll be focusing mainly on just doing exercises and getting used to creating these parameters and publishing these workspaces. Let me see here. Yeah, so this is a good one. We'll start with this. So we're on exercise 3.3. We're going to be looking at adding some published parameters into the workspace that we've built so far. So I'm going to open up Workbench again. Then we can open up our starting workspace. So if you need a fresh start, you can always grab the starting workspace from here, self-serve exercise 3 begin. I'm just going to reuse the workspace I had from before. So it's my self-serve exercise 1 complete. So your workspace should look like this. We've got our GeoTIFF reader, a raster resampler, a raster mosaicer. I'm just going to reorganize this to see it, and our JPEG writer. So again, if anyone joined late, you can use the starting workspace to get going. This is the same workspace that we built yesterday as well, so you can use that one to begin as well. So what we'd like to do is let our end user decide exactly how the output's going to be created. So one thing people want control over is the resampling. So currently, our raster resampler is set to give it an X and Y cell spacing of 5. Our end users would like to be able to set that higher or lower depending on their needs. So we're going to create a user parameter for them to set that. So let's work on creating a user parameter for our X and Y cell spacing. So we can do that from the navigator window inside Workbench. I'm just going to move my parameter editor to see that. So it's on the left-hand side here. In the navigation, we can look at user parameters. We can see we currently have 3 published parameters. So these were created by default. So when we add any new reader or writer, it'll automatically publish the source location or the destination location. We'll leave those as they are for now. What we want to do is add a 4th parameter for our cell spacing. So we're going to do that. Just locate user parameters in the navigator and right-click. And that'll open up our little context menu here. You'll have the option to create a user parameter. So that'll pop up our add/edit user parameter dialog. You'll see at the very top under type, you have a list of all of the different types of user parameters you can create. So there's quite a lot of variety in here. So it's definitely worth taking a look at the list and just seeing if there's anything that makes sense for the type of parameter you'd like to be creating. So you can have lots of different types of choices here, multiple choice, choice or text, where you want someone to be able to choose from a list or type in their own values. You have color pickers, dates and times, file names, folders. These are the 2 scripted parameters here, Python and TCL. Password's a good one if you want people to write in a password but not have it displayed in plain text for all the world to see. And there's quite a few others as well. For what we need, we just want a number type parameter. So locate number in this list. So we can give our parameter a name. So this would be something just to make it easier to identify what this parameter is all about. So we can call it cell spacing. Beside the checkbox, we can decide if we want this to be a published parameter. So leave that checked because we want our users to be able to set it. And we can decide whether or not this value is optional. So we're going to uncheck optional to say that it is not optional. The user will have to set a value of some sort here. And then for prompt, this will be the message that pops up when the user goes to run this workspace. So we want to give them enough information to know what kind of value they're setting. So for our prompt, we can say enter resolution, and we want them to set it to a value between 1 and 50. And then finally, under configuration, we want to make sure they can't enter anything other than a value from 1 to 50. So you can click on this little browse button next to configuration. and that'll let us set the range of values that we expect our users to put in. So for our lower limit, we want to make sure it's always greater than 0. So we can change that from none to greater than value. And the value we want it to be greater than is 0. And then for upper limit, we want to make sure it's always at most 50 or less than 51. So we can say less than value and set that to 51. For precision, we don't want them to put in a decimal, so we'll just say 0. So they won't put any decimal places. These would be integer values only. Once you've got that set, so we've got greater than 0, less than 51, decimal places are 0. We can click OK. And you'll see that transfers into the configuration window here. And then we can set a default value for this parameter. So when a user goes to run it, it'll have this value pre-populated in there, and they can change it if they want to. So our default will be 50. When you're ready, you can click on OK to create the parameter. So you'll see now you've got 4 published parameters listed inside your workspace. So this is great, but at this stage, all we've done is create a parameter that they can set that does absolutely nothing because it's not applied to anything in our workspace. If we take a look at our resampler now, you'll see it's still set to 5, so it's going to ignore the value that we put in here because FME doesn't know that we want to link those two. So our next step will be to apply this parameter to the values from our raster resampler. So we can do that by opening up the parameters for the raster resampler transformer. So click on the cogwheel or double click on the transformer to open it. Then we want to set our X and Y cell spacing to come from the value of this published parameter. So to do that, we'll want to click on the drop-down arrow on the right-hand side of these parameters. And down below here, we see user parameter. And we can link this to any of the user parameters we have. So one option I'll just highlight quickly here is you have the ability to create a user parameter directly from this dialog. So it's simply another way to create a published parameter. So you could click on this and create the cell spacing directly from within the transformer. So it's handy if you're working inside the transformer and you realize you want to publish something while you're in there, you can do it all at once together. In our case, since we created the parameter first, all we need to do is select it when we choose our user parameter. So under here, we can locate our cell spacing parameter and then click on that. When it's selected, you'll see the value changes. It'll have this little icon indicating that this is a user parameter or it's been published. And it has this little $ cell spacing. And that just indicates which of the parameters it's linked to. So let's do exactly the same thing for our Y cell spacing next. So we'll click on the drop-down, locate user parameter, and we'll link this to cell spacing. So both our values will be set to the same. We'll always have square cells with this. You could optionally create separate published parameters for this. You could have a Y cell spacing and an X cell spacing parameter, but in our case, we don't mind having them set to the same. So let's click OK to accept that. And finally, we're going to be creating one more user parameter. So the other option we'd like our users to have control over is found inside the JPEG writer. So I'm just going to open up the feature type and show you. Down below here, we have this compression level. So it's currently set to 28, which is just the default value for this writer. We'd like our users to be able to decide how compressed they'd like the output file to be. So I'll just exit this, and we'll create the new user parameter from the navigator window. So we'll be using a different parameter type this time. So under published parameters, just right-click in there and choose Create User Parameter. So this is exactly the same thing that we did before. Under Type, this time we want to set this to Choice with Alias. And it'll just be a single choice, so make sure you just select Choice with Alias and not the multiple. We can give our parameter a name, so we'll call it compression just to be descriptive. And again, we'll make sure this is not optional, so uncheck that box. For prompt, we'll just say select compression level. And then configuration, we're going to set it up as shown in the manual. So I'll click on the Browse button here, and that'll open up our Choice with Display Name editor. So you can see here, we can set a display name on the left-hand side and the value that will be submitted on the right-hand side. So for our output, for the JPEG writer, it expects the compression to be set to a numeric value between 1 and 100. For our end users, they don't necessarily know what this means, so we can create a display name that they can select instead. So we're going to set this from none, so no compression, all the way up to high, which would be a value of 75 in our case. So let's set up the dialog as shown here. So the first one will be none with a value of 0. Then we'll have low with a value of 25. You can use tab to move through these as a quick shortcut for that. Next we have medium with a value of 50 and high with 75. I'll give you a second to finish inputting that. Okay, once you're ready, you've got these 4 options listed here. We can click on OK. And that'll populate our configuration. For this one, we're going to leave the default value empty. So we're going to make our users make that decision, and we're not going to give them a default value at all. Then we can click OK to create the parameter. So like before, we've now created a published parameter that doesn't do anything yet because it's not linked to our actual value. So we need to apply that to where we want to set this within our workspace. So this one's set on our JPEG writer. So we can locate the JPEG feature type in the workspace. Click on the cogwheel or double click on the feature type to open the parameters. Our compression level's at the very bottom here, so it's in this little collapsed group. Click on the arrow to expand it. And our compression level's at the top, so let's see it has a value of 0 to 100. And let's link this to our compression user parameter. So you can click on the drop-down arrow, exactly as the same as we did in the raster resampler. Under user parameter, we'll locate our compression parameter. And you'll see it looks like this, indicating that this is now published. Let's click OK to accept that change. So I'm going to save a copy of my workspace now. And then I can run it just to see the difference. So I just clicked on the Run button at the top. You'll see this little dialog that pops up with the parameter values, and you'll see we've got these two new ones that have been added. So you've got our resolution with the default value we've set, and the compression level with the list of 4 options that we've configured. So you can select one of those and click Run just to make sure the workspace still works. And you should see it ran successfully. Once you're satisfied with that, let's publish this workspace up to FME Server and take a look up there as well. So I'm just going to File and Publish. The usual training connection. And we can publish this workspace. I'll just leave it as the same name. You could just change the name as well, depending on your preference. And for this case, we'll want to make sure we're registered with the data download service. And click Publish. Workbench is not happy in here right now. Okay, so we've got that published. So let's go up to FME Server now. And let's run the workspace. So under my last published workspaces, I'll just use the link for that. You could just go to Run Workspace and select it. I like this as a quick shortcut. For service, make sure you've selected Data Download. And we should see we've got those 2 new options that are configured in here. We've got a resolution with a numeric value, so we can use these arrow keys to click to set that, or we could type in a number. And then we can also set our compression level anywhere from none to high. So choose an option for either of those. Doesn't matter what values you pick, you'll just see different results depending on what options you have. I'm going to set this to 45 actually. And then I'll run the workspace. Let me just download the results here and take a look. I should see, first of all, that the file size is quite a bit smaller than it normally would be. And if I open this up, it's also super tiny. So that's what we did by adjusting the resolution here. So it's now a very low resolution, very compressed file. So you can see that's dramatically different from before, as we've been able to change what the workspace does by setting these parameter values. So depending on the values you set, you might see this have higher or lower resolution and be smaller or larger, depending. Okay, so that brings us to the end of that exercise. I'll just do a quick show of hands. Did everyone successfully complete that? Awesome, that's a good number of hands. I do see one question about the source field. If you're seeing that it's not pre-populated, I just go back here. So if you're seeing that there's no value in here, it's probably a step just missed in the publishing process. So if you go back into Workbench and open up your workspace, so I'll just go through File and Publish. You might need to double check that Upload Data Files is checked just to make sure your file is selected in there. So that's probably what's missing if that value is not set. So just make sure when you're publishing that you upload your data files. Okay, fantastic. We're going to look at a little bit more theory before we move on to the next exercise. So if you are still just finishing that up, don't panic. You can test it out. I think you'll have a bit of time. So what we're going to do is we're going to go through one more concept and one more exercise before the break. So we're just looking at a different type of parameter for this one. So these are two options that are very commonly used when you're creating self-serve systems. One's for format and one's for coordinate system selection. So for format selection, we have a special writer within FME called the generic or any format writer. What this one does is it has inside its parameters, here, let me open that up again. Inside its parameters, it has a parameter option for the output format. So when you set up this writer, you can actually choose at runtime which format you'd like to write out to. So in this case, this one's writing out to the Tableau data extract format, but you could choose from any number of other options there. One key thing to keep in mind if you're using the generic writer within your workflows is in most cases, you don't want the user to have the option to select any of the formats in FME as an output. Not all of the formats are going to make sense for the type of data you're working with. For example, in our case, if we're dealing with raster data, it's going to be difficult if we decide to write that out to a text file, or if we let the user write out to something else, trying to think of another example, like GML. There's a lot more transformation that needs to take place in order to make a raster file compatible with something that's generally just a text file. So when you're creating a generic writer, you generally want to create a published parameter for the format and limit your users to a selection of formats that make sense for the type of data you're working with. By default, when you add in this writer, it's going to give you the full list of every format in FME. So you might run into weird issues if people are working with incompatible formats. Another thing to keep in mind is if when you add in the generic writer, it's automatically going to create a published parameter for the output format, and we'll see that in the exercise coming up. When you run the workspace in Workbench with that default parameter, it will give you a dialog to let you select from a list of options for the writer. But when you publish that up to FME Server, since FME Server doesn't know what the full list of writer formats are in FME by default, it's going to convert that output format field to a text field. And that text field expects the short name of the format that you're going to be writing to. So if you use that default parameter, you're kind of assuming that your end users have the short name of every format in FME memorized and can input that themselves. So in general, you want to adjust that parameter to give them a list of options instead, just to make it easier on them. One note though, if you are planning on, say, running these workspaces programmatically, then it doesn't matter because you'll probably pre-populate it with the appropriate format short names yourself. So it depends on how you're going to be running the workspace. Another parameter type that is very useful is the coordinate system selection. So you can always locate the coordinate system output field and create a user parameter from that to let your end user select the coordinate system of the output data. This gets into just some step-by-step information for how to do this. Since we were doing this in the exercise, I'm going to skip over this for now. It's nice when you can see it and practically use it for yourself. So let's hop into exercise 3.4 and we'll take a look at how to publish your destination coordinates, your destination format, as well as your destination coordinate system. So we're continuing on with the workspace we've been building. Again, if you need a fresh start or if you're just catching up right now, the starting workspace is found right here in the FME Data 2019 folder. It's called Self-Serve Exercise 4 Begin. So I'm just opening up Workbench here. And we're we're continuing on with this workspace. We've got our GeoTIFF reader and our JPEG writer. So this is great, but this workspace will only ever create JPEG files because we're using a JPEG writer inside of it. So what we'd like to do is replace this writer with the generic writer instead. So our first step will be to add in the new writer. So within Workbench, locate Writers from the top menu. And we'll say Add Writer. For writer format, just type in generic, and that should pop up. So it'll say generic, any format. For writer dataset, we'll select that to the output folder in FME Data 2019. So I'll just click on the File Browse button. We'll locate that. So just in the top here, I'm just going to click on FME Data 2019. And we'll go to the output folder. If yours didn't start there, you can always use the shortcut to go to FME Data 2019 from the left-hand side. We'll just select Output, and we'll say Select Folder here. So your dataset should look like this. You'll see Parameters has this little red exclamation mark next to it, meaning we have to set something in here before we can add this writer. So click on the Parameters button. We can see that it's asking us to set the output format. So this generic writer can't do anything unless it knows what kind of format it's going to write out to. So we need to set this to a default value so it knows what to do if no one sets it. So our default, let's set that to JPEG. We'll say JPEG. Choose the top options, the Joint Photographic Experts group. Under Mime type, we can set that. So because this is the generic writer, it could write out any type of file. So we'll set the default Mime type to match our JPEG. So I just clicked on the drop-down and I'm selecting Image JPEG. In this case, it doesn't really matter too much because this only applies if we're running with the data streaming service. So we're okay for now, but it doesn't hurt to set that. So for the data download service, this won't matter because it'll always download a zip file. When you're ready, you can click OK. Under feature type definition, make sure that's set to copy from reader. That should be the default. And we'll click OK. And you'll see we now have an additional feature type added to our workspace, which is basically identical to the JPEG one. One thing I recommend doing, especially if you have two feature types that are exactly the same, is adding a little annotation to each of them just to help you distinguish which one's which. So I'm just going to right-click on each of them and locate Attach Annotation. So this is optional, just makes it easier to handle. So I just right-click on the feature type and say Attach Annotation. And I'll do the same on my generic. Right-click, Attach Annotation. So now I know which one's which for when I'm working with this in the future. Our next step will be to actually use the generic writer instead of the JPEG writer. So we're just going to move the feature type or move the connection from our raster mosaicer over to the generic writer. You could optionally just delete the connection and then redraw it to the generic writer instead. So we could just delete the JPEG writer completely from this workspace to clean that up, but we are using a parameter inside here. So one thing that's interesting about the generic writer is that if we look at it, it really doesn't have any options because it's supposed to be generic, so it doesn't have any format-specific information inside of it. So if we want to, say, use a generic writer to write out to a JPEG file, but we'd like to actually set the compression level because that matters to us. What we can do is leave in a dummy writer, so one that's not connected to anything, same way our JPEG one is. And when the generic writer is configured to write out to JPEG, it will actually look at the workspace and see if there is a JPEG writer inside. If there is, it will use any settings that have been changed on that writer. So it gives you the ability to publish parameters that are specific to certain format types and control how certain formats are written out without having to have 5 different writers in your workspace for each of the different output types. So you can use one generic writer and have these other writers just kind of floating there so you can use their parameter values. Okay, so our next step here will be to create a user parameter for our output format. So we'll use the usual procedure to do that. I'm just going to take a look at the user parameters right now and show you what we've got. And you can see that the format generic, the output format, has been published by default. We don't want to use this default one because it'll turn into a text field in server, which isn't super useful. So we're going to create a choice with alias so that our users can select from a list of options that we've defined. So right-click on User Parameters in the Navigator window, and we're going to create a new user parameter. For this one, under Type, we're going to choose Choice with Alias. There we go. We'll give it a name, so we'll call that Output Format. Again, this one will not be optional, so uncheck that. And for prompt, we'll say select the output format. And then configuration, we'll set that up. So let's click on the Browse button. And so we have a couple of options here. The first thing we can do is simply type in the choices that we want. So if I know the short names for my different formats, I could just type in the values here and put in a display name myself. If, like me, you can't remember them because there's a lot to remember and there's no need to memorize these, we're going to use the Import button to import these. So click on Import, and you'll see that we can import a few different things. So we can import a list from a pre-existing data set, which is handy in some cases. For our scenario, we'd like to import from the list of writer formats in FME. So under Import, we'll select Writer Formats. So this brings up the writer format dialog, and there's little checkboxes on the left-hand side to let us select the formats that we'd like to include in our list. So for this workspace, we're going to choose 3 different output formats. The first one will be GeoTIFF. So in the search at the bottom, just type in GeoTIFF, and you should see that pop up in the filter. Click on the checkbox to select it. And then we'll do the same for the other 2. So we're going to use JPEG next. Make sure you select the top one, not JPEG 2000, so just the regular JPEG format. And then finally, we're going to go with PNG. Again, you'll see there's 2 PNG formats. Just choose the regular one, not the rasterizer. So we're just choosing the regular PNG format. When you're done, your list should look something like this. You'll have 3 formats selected: GeoTIFF, JPEG, and PNG. You can see the short names for those formats beside them. When you're ready, click on OK, and that'll import the list into our Choice with Display Name dialog. So you can see our display name here. We could optionally edit this if we wanted to give them different names depending on what our users might expect. So people may not care that this is georeferenced tags image file format. They might just care that it's GeoTIFF. So we could remove that from our description if we wanted to. I'll just leave them at default because that's easiest for now. When you're ready, click on OK. And then finally OK one more time to create our published parameter. And again, we've just created the parameter. We haven't linked it to anything. You'll also notice that we have our pre-existing output format parameter in there as well. So we want to make sure we link the one we just created to our generic writer. So in the navigator window, locate the generic writer. We'll expand it. And then go to parameters and expand that. It's a little bit buried. You'll see the output format. So you can see it's currently linked to format_generic. We want to link that to our output format parameter we just created. So to change that, just right-click on the output format and choose Link to User Parameter. So we've right-clicked on the output format and we're selecting Link to User Parameter. This will give us a dialog to let us choose which of the user parameters we'd like to link to our output format parameter on our writer. So you can click on the drop-down and then locate your output format parameter that you'd created just now. So there it is. So you've selected output format. Then click on OK. And you should see this now changes to be linked to output format. You'll see that it's colored red right now, and that's because we don't have a default value for our output format, which just indicates it's not set and that our user has to set this in order for this workspace to run without an error. Okay, and one last change before we finish off this workspace. We're going to follow a very similar set of steps to publish our output coordinate system parameter as well. So on user or published parameters, just right-click and choose Create User Parameter. And then we'll set the type to choice with alias. And then we'll set it up as shown in the training manual. So our name, we'll call it Output Coordinate System or CoordSys. For those who don't like to type too much in here, we'll make sure it is not optional. And we'll give it a meaningful prompt. Select the output coordinate system. And then we'll configure this one. So click on the Configure button. And we can import from the list of coordinate systems. So click on Import, very similar to before. And this time we'll select coordinate systems. We're going to import from the list of coordinate systems in FME. This one's a long list, so we're going to select 3 of them to let our users decide which coordinate system they'd like their data in. Again, this is another example where you probably don't want them to select from the full list of every coordinate system for everywhere in the entire world, because this data is located in Vancouver. Probably doesn't matter if they have the option to select a coordinate system from southern Finland, for example. So the coordinate systems we'll select are these 3. So the first one is LL84. So in the search filter here, just type that in. You'll see there's a bunch of different versions of this. A lot of them are the same actually. So these top 4 are all LL84, just with slightly different naming conventions to make it easier to spot the one that you'd expect. We'll just select LL84 here in the middle. Then we'll look for BCALB83. -83. And that'll be an equal area projection. So we can choose that one. And the final one will be UTM83 zone 10. UTM 83-10 when you search. And we'll grab the top one. This one's in meters. That's what we'd like. So click on the checkbox to select that. So you should have 3 coordinate systems selected: BC ALB 83, LL 84, and UTM 83-10. Now I'll give you a minute just to make sure you found those all. We can click OK to import that. So our list should look like this now. Again, you can always adjust the display name if you'd like to make that clearer or just easier for your users to read. These are quite long by default. I'll just leave them at their default values. And then let's click OK to create that parameter. Oh, and OK one more time. That creates the parameter. So we've got our output coordinate system now. And then again, as before, we need to apply this to our workspace. So back in the settings for our generic writer, so we're in the navigator window here under output generic. You can see there's this coordinate system parameter that's currently not set. When it's not set, it'll simply take the same coordinate system as the input data. Let's link this to our published parameter now. So I'm going to right click and say link to user parameter. And then we'll locate our output coordinates parameter in the list. So we've got output coord sys here. And click OK. You'll see the icon doesn't change, and that's just because it's got this fancy coordinate system one instead of the gear, and that's completely fine. You should see that it says linked to output coord sys there to indicate that it is published. So let's save the workspace. We can run it just to take a look at the parameter values, and we can see we've got our 2 new parameters for our output coordinate system, as well as, our output format, and then our output coordinate system. So let's publish this up to FME Server now and take a look up there and see how this has changed things. So we'll go to File, Publish to FME Server. Go through the usual dialog. Make sure you select to upload your data files. This time we do need to make a change in the service itself. So under data download at the top, click on edit. So in the properties, you'll see that it says include writers in download, and it's currently set to the JPEG writer. So if we publish this and ran it, we'd actually get no output because our JPEG writer is not currently connected to anything. So what we want to do is adjust this so we include our generic writer in our download. So click on the little browse button, and it'll give us a list of the writers in our workspace. So we want to check the option for the generic writer and uncheck the JPEG writer. All of our data is coming out through this one, so we only need the generic writer selected. Click OK. And you should see it looks like this now. Include writers in download is set to generic. Let's click OK again, and then we can publish. And let's go into Server now. I'm just going back to the home page, and I'll select from my last published workspaces. Make sure your service is set to data download. And let's take a look at our options here. So we've got quite a few published parameters going, so we can clean this out in future exercises. and delete some of the ones we don't care about. But let's try it with some values here. So I'm going to set the resolution to 1 instead. I'll do medium compression. For output format, you can select anything you want, GeoTIFF, JPEG, or PNG. I'll select PNG to be different from before, and we can choose whatever coordinate system we want. I'll do equal area. And let's run this workspace. I'll just download the output and take a look. If you selected GeoTIFF, you won't be able to view it very easily unless you have FME or use FME in here. That's why I picked PNG for this one. So I'll open this up. And you should see we've got a PNG file this time, different from the JPEG. And you can see it's kind of rotated a little bit just because of the new coordinate system that we've selected. So that's looking good, and our workspace is doing exactly what we need here. So let's just do a quick show of hands. Everyone see that output and see that the new data file was created with those published parameters? We'd like to get started on Chapter 4 and start looking at automations in Server by the end of today. So for the last couple of exercises here, instead of building them together, what we're going to do is just start with the finished workspace, and we'll just take a look at what we did to modify those. So just for the sake of time, we're just going to be using the completed exercises for the next 2, just to make sure we have enough time to cover automations and the rest of the training with enough detail, and we don't have to rush too much through everything else. So the next couple of sections here are just talking about other types of parameters and ways to author your workspace to provide your users with the ability to have more control over exactly what happens within the workspace. So one concept here is looking at layer selection and handling. So spatial data is often organized in different types of different layers. So this could be tables if you're working with a database, groups, classes, categories, feature types, lots of different ways to describe what this is, but it's just different groupings of the data itself. So in FME, we want there to be lots of flexibility in being able to select which feature types you read into a workspace and which feature types you write out. So for selecting layers, so each reader in FME has a parameter called feature types to read. So you'd see this generally kind of buried a little bit in the parameters. If you look at the reader, inside its parameters, there's this features to read section. And at the very bottom, there's a feature types to read. So this would correspond to reading in the different layers or the different tables or the different groupings of your data, depending on the kind of data set you're working with. In this case, this is dealing with a file geodatabase. So this is mapping to the different tables inside that geodatabase. So this feature types to read parameter lets you select which layers you'd actually like to read into your workspace. So what's interesting in this one is this workspace was added and all of the different tables from the geodatabase were included as feature types. So there's 8 different feature types in the workspace, but when they ran this workspace under feature types to read, they only selected 3 of them. So they're actually only reading in 3 of the layers, even though they could have read in all 8. So it's just another way to limit the kind of data that's coming through and the kind of information that's going to be written to the output. So you can publish the feature types to read parameter for any of the readers, and that'll bring up a dialog that looks something like this. Or sorry, when you click on the feature types to read, this is when you go to publish it. You'll get a dialog that looks a little different from the regular publishing, the regular user parameter dialog. So it'll give you a list of all the feature types. These would be the ones that have been imported into the workspace. You could optionally import the list from the dataset itself if you haven't imported everything. This parameter type has the option to use an alternate display name. So if the layers in your dataset aren't super meaningful for the people who would be selecting the layers they want, you can use this alternate display name option to provide more user-friendly titles for each of the different layers. And similar to all the other user parameters, you can set a name and a prompt for the parameter you're creating. Another interesting concept is the idea of grouped layers. So depending on the kind of data you're working with, sometimes you don't want to give the user access to the full list of every table that's inside your data set. Sometimes those tables can kind of be grouped logically into more broad categories. So you can do this using that feature type list and using the use alternate display name option when you're publishing the feature types to read. So in this case, the data that's being read in is a set of different types of roads. So maybe your users really don't care if they're arterial versus residential roads. They just want to be able to download all of the roads. So what you can do is you can give all of the different layers that belong in a group the same display name. So now when you go to run the workspace, instead of seeing, if there were 8 different layers and you created 3 different groups for those layers, instead of seeing 8 options, they would only have 3 with each of the unique display names visible. So in this case, this user's created several grouped layers, including roads and buildings from their data set, and they're able to show just the group layers instead of everything in the data set itself. So in exercise 3.5, we're looking at how to allow for layer selection within our workspace. So for this one, we're just going to be skipping to the ending workspace just to take a look at what we've changed. There's a fair bit of steps in this one, so it'll take a while to go through, and we unfortunately don't have enough time to go through everything, but we're going to open up the workspace and take a look at what we'd need to do to configure this in the workspace we've been building. So for the beginning, we'll just open up the ending workspace here. So we're starting with the ending workspace. I'm just opening up Workbench here. And I'm just going to go to File and Open. So the workspace we're looking at, or looking for, is inside FME Data 2019. Again, you can access that from the shortcut. We'll look inside Workspaces, Server Authoring, and this one is called Self-Serve Exercise 5 Complete. So down near the bottom here, we've got Self-Serve Exercise 5 Complete. So we'll make sure we'll select that one. When you found that, click Open to open the file. So we'll see this is basically the same workspace we've been handling up until now with a few new additions. So the first addition was that we added a new reader. So with our first data set, we had some raster files, but there's no real layers inside a raster data set. So we're adding in a new file with some actual layers inside of it so we can publish that feature types to read parameter. So we've added in a Bentley MicroStation design file. This one, if we inspect it, so I'm just using the View Source Data button on top. There we go. So I'm just showing you what it looks like in here. So it's just a set of road data. So you've got a few different types of roads. And what we were doing in this workspace is we're taking this road information and we're using the vector on raster overlayer transformer to take the vector data from our roads, so those line information, and we're basically stamping it on top of our raster data. So if I run up to this point, just have to select some values here. So you can see we've got our two user parameters here, the vector tiles to read. Just select a bunch of those. And roads to overlay, I'll just select all. So you don't necessarily have to follow this. I just want to show you what it's doing. And you can see here, if I pan, we've got our raster data with the vector lines stamped on top of it. This looks a bit rough right now, just because I'm not zoomed in very well, but that gives you the idea. So we've created a single raster file with our vector lines on top of it. So that's basically the only change we've made to the workspace, is we've added in this new transformer and the new reader. The other thing we'll look at here under published parameters is that we've published the feature types to read for both our raster reader and our GGN reader. So under DGN, you can look for it in here. Click the drop down and locate features to read. We've got the feature types to read parameter published. So I'm going to right click on this and choose Edit User Parameter Definition just to take a look at how it's set up. So if you want to follow, we're in the DGN reader. Under Features to Read, looking at Feature Types to Read, just right click and say Edit User Parameter Definition. So it's a very bottom option. And you can see what we've got set up here. So we've got the list of all the feature types in this data set, and this corresponds to different types of roads within the city. So we've got secondary roads, residential, collector, arterial, and so on. And we've chosen to add an alternate display name for these, and we're using the concept of grouped layers. So instead of giving all of these different options, we just want them to be able to select from primary roads, secondary roads, and other roads. So we're going to give them a list of 3 options instead of 7. So that was the first change. The second change was to clean out the published parameters in this workspace. So you can see before we had a whole bunch of different published parameters. So we just deleted some of the ones for the source data sets and our destination data sets. So we don't need to set any of these when our users are running the workspaces. We just want to give them options to customize what happens when it runs. The other thing that we changed was before in our workspace, we had it set up to only be able to read in one GeoTIFF file. So the reader name had the name of that one GeoTIFF file that we'd selected. So one of the things that we changed in here was to turn on a merge feature type. What this does, as you can see from the title of the feature type, is it's now set to all. This means it can now read in all of the different raster files from the orthophotos directory. So if you remember when we set up this workspace, there were probably 20 or 30 different raster files in there. So now we'd like our users to be able to select whichever ones they'd like to download. So this merge feature type is what's allowing us to read in any of those, not just the one that we set up the reader with. The other change in here under source GeoTIFF files is instead of having just one file selected, is that we've selected all of the files inside the orthophotos directory. So all of them are now listed in the source file. So you can see if you highlight over it, you've got a very long pop-up with every single TIFF file in that directory. And finally, under feature types to read here, we've created another published parameter. So I'm just going to look at the options in this one. Under edit parameter definition, you can see this corresponds to each of the different file names inside my raster orthophotos directory. So you can see there's a bit of a difference in the feature types to read parameters for either of these readers. So with the raster dataset, feature types to read corresponds to which files to read. So it corresponds to the file names. In the case of DGN, this corresponds to the different layers within the file. So these are not the file names, these are the layers in the data set. So you'll see, depending on the type of data you're working with, the feature types to read will have slightly different meanings to match up with how the data is structured. So now that we've got this workspace completed, we can publish this up to FME Server and take a look at what these new parameters can do. So looking at your complete workspace, let's publish this to server. So we'll say File and Publish. We'll go through the regular publishing steps. Under Upload Data Files, you'll notice that it's now 41 files, so it's all of the files in that orthophotos directory, including the addition of the DGN file, so that's the one. So there's 40 files in orthophotos. For workspace name, you can leave that at default, that's totally fine. Make sure the data download service is selected. We can double check the properties to make sure we're writing out to the generic writer, so that's set there. You might notice that the top part's a little long, and that's just because it's including all of the file names from our input. And then click on Publish. So it'll take a little longer than normal because it needs to publish all 41 files with it. You should see those all uploading in the translation log down here. So you see all of the files listed that were published with the workspace. I'm just going to scroll up above the list of files. I'm going to use the direct link to go straight to my workspace. So this is a good shortcut as you're authoring workspaces. This will always give you a link to open up the workspace directly in FME Server. So I'll click on this link, and that'll open up over here. It is the regular run page, there we go. And you can see it just opens up directly to the workspace I just published. And it has my data download service selected. And now I can see under raster tiles to read, so this is the new publish parameter. I have a drop down where I can select all of the different raster tiles that I want. So you can select any number of those. You could also choose to select all of them. So that's what I just did. So I just clicked the checkbox at the very top to select all of them. You can choose which roads you'd like to overlay. So this is an optional parameter, so you could leave it empty. For this one, I'm just going to select primary roads. And then we can use our output coordinate system and format parameters that we'd created before. I'll go with PNG for this one. I like to keep the resolution a little better just so I can actually see the output. So set that to somewhere closer to 1 instead of closer to 50. And I'll click Run to test this. So for you, you can set those values to whatever you want, and you can just see what the output creates in this case. Because I selected all of the files, it does take a little bit longer to run. There we go. This will be a decent sized PNG, I think. Yep. And here's my output. So I can see my data here. I've got a little bit of Stanley Park showing up there in Vancouver, and then I've got this red lines indicating the primary roads in the area. If you selected fewer files, you'll see a smaller image of a smaller section of the city of Vancouver. If you're unlucky, you might have ended up with some white ones, so if you don't have anything visible in your output, you could have selected some of these empty tiles by accident. So I'll just do a quick show of hands here. Is everyone able to run that and see the output? Awesome. Does anyone need a few more minutes to look at this? Okay, great. So I'll just move on to one more concept here. So again, this one's related to setting up the workspace so that people can have control over what the output's going to create. So in this case, so in the last one, we looked at creating feature or publishing the feature types to read, so users can select which layers they're interested in getting data from. Another option instead of that is to let your users select kind of an area that they're interested in downloading data from. So in our current workspace, we have data for all of the city of Vancouver. We'd like them to actually be able to select an area that they'd like to download data for. So instead of selecting the tile names, because the users may not know what 0203HI refers to, we're going to adjust the workspace so that they can select the neighborhood for the city that they'd like to download the data from. So this is done using Geographic Selection. So within FME, there's three kind of key ways of being able to configure Geographic Selection in a workspace. First one's using a simple rectangular bounding box. We'll look at how to do that. Another one is to use an existing boundary. So in our example, it would be the area or the boundary of a neighborhood. It could be something like a regional boundary. So if you want to download data by country or by province or by state, something like that. It could also be municipal, so within the cities. It could be anything that makes sense. So you could do zip code boundaries, anything like that. And then finally, you can do an ad hoc boundary. So it'd be an area of interest that the user might draw on a map so they could select the data they want. So this here has an example of one of our FME server demos that shows doing that. So in this case, you can draw a polygon on a map of Vancouver and download specific layers for that area that you'd like to download data from. So the first and simplest way of handling geographic selection is through a bounding box, also known as a search envelope. So it just defines a rectangular area of interest by which you can download data. So all readers in FME have this search envelope parameters. So you can see that in this workspace. So I'll just show this. You don't necessarily have to follow it. There we go. Under parameters, you'll see search envelope, and this will have all of the options for setting up the search envelope parameters. So you can put in an XY coordinate for each of the corners of the bounding box that you'd like to read data from. This will limit the amount of data that the reader pulls into the workspace to just that specific area. There are a couple of additional parameters associated with this. The first is the search envelope coordinate system. So if you'd like to pass in coordinates in lat long, for example, that have come from a map that a user's drawn, you can set the coordinate system for the search envelope in case your source data doesn't match the same coordinate system as how you're specifying the search envelope. So if your source data is in UTM-83, but your search envelope's in lat long, you can set up your search envelope in lat long, just tell FME what coordinate system it is, and then it will reproject the bounding box to match up with the coordinate system of your input data so that they'll overlap and you can download just the data in that area. The other option here is the ability to clip to the search envelope. So when that's set to no, it will read in all of the data that overlaps with the search envelope in some way. So if you have a really long line that happens to intersect the search envelope and continue on for a while after that, if you have clip set to no, you'll import the full line, even though parts of it extend outside of the search envelope. But it does leave that geometry intact. If you set clip to search envelope to yes, it'll clip off the line where it exits the search envelope. So if you have polygons or something like that that extend outside of that search envelope, you'll see them clipped to the boundary of the search envelope. So you'll have kind of a squarish chunk cut out of them. So that all depends, how you set that depends on what you care about when it comes to setting up the search envelope. Okay. So next we can look at existing boundaries. So by existing boundary, we mean being able to use the perimeter of a non-rectangular geographic area. So this could be something like the boundary of a country or a zip code boundary or a census area, anything like that. There's a couple of different ways to be able to clip your data to an existing boundary. So the first option, here we go, is to make use of a tester transformer. So if you have a reader, for example, in this one, we've got garbage schedule, and this is divided into multiple polygons with their own unique zone or subzone values. So one thing you can do is just create a published parameter where a user could select the zone and the subzone they'd like to download data from. And then you can use something like a tester transformer to filter based on that. So you can say, if the user's input value matches the current zone, then we'll send that data to the output. If it doesn't match with what the user selected, it will fail the test and then not be included in the output. So this is a good way to filter the data as it goes through. Another option is to make use of a feature reader transformer. What this one does is it has the ability to set up a spatial filter. So what you can do is you can read in your data, find the pre-existing boundary that your user cares about getting data for, send that boundary feature into the feature reader. So that'll go into the initiator port, and then you can set up your real reader to pull in the data that you'd like to send to the output. So in this case, we've got a list of addresses from a file geodatabase. And using the garbage schedule example, we've got a polygon outlining the garbage zone that the user cares about. So that polygon will be sent into the feature reader. When we have the spatial filter set to initiator contains result, this will check that boundary of the feature that came in and only bring in the address points that fall inside that area of interest. So it's a good way to send in a boundary and only read in the data that falls within that boundary. I'm just going to drop in a feature reader just to show you this parameter. So you have a few different options in here for the different kinds of tests you can do. So these are all just different types of spatial tests that you can perform based on the input data, and you can decide how much of the data from the reader you're setting up in here will get brought into the workspace based on the results of these tests. Another option, so with this, using the feature reader, this will only read in the data that falls within the zone you care about. You could also use a clipper transformer to do basically the same thing. The difference with this, as you can see here, we've got our address points data. We read in the full data set, then we send it to a clipper and clip out anything that doesn't fall within the zone we care about. So this one will do exactly the same thing. The big difference here is that it's a little bit more inefficient because you're reading in all the data and then throwing out what you don't care about. So there's 12,000 features here that you read in that you're just throwing out anyway. So if you use the feature reader, you don't even look at these 12,000, you just pull in the 955 that matter to you. This is useful though in some cases where you actually do care about what's outside, so you can do some other work with that. So it all depends on what you need to do in your workspace. And then finally, ad hoc boundaries. So looking at a boundary that a user drew, you can pull that into a workspace as well. So it's generally done using a published parameter. So in this example here, we have a published parameter called geometry string. And then basically you're passing in a string definition of the geometry that shows the area of interest that the user selected. So you could send that in as well-known text or XML or any other format that FME can recognize. Then you can parse it in the workspace and create a geometry based on that. So what we have here, we've got an attribute manager that's pulling in the value of the geometry from an attribute or from a published parameter. It's then using the geometry replacer transformer to take that geometry string that was sent in. Since it was sent in using well-known text, it can replace that with an actual polygon instead. And then we're sending that polygon into the feature reader, or we could send that into a clipper or anything else in the workspace. So let's look at exercise 3.6 to see how we can set that up. So for this workspace, we're going to be building off of this again. We'd like our users to be able to select the neighborhood they want their data from. So instead of having to select some arbitrary set of raster file names, they're going to select the neighborhood they care about. So let's start with the finished workspace. We're going with exercise 6 complete for this one. So I'm just going into my workbench, so you can open that up if it shut down on you. We'll go to the File menu to open up the ending workspace. So say File, Open. We're looking at Self-Serve Exercise 6 Complete. So it should be the one at the very bottom of this folder. And we'll click on Open. So you'll see that there's yet another reader in this workspace now. We've got a Kml reader that is pulling in information about the boundaries of all the neighborhoods in the city of Vancouver. So I'll just open that up to inspect it. You can see there's just a set of a few different polygons outlining the locations of different neighborhoods in the city. We have a tester transformer in here that's filtering out the specific neighborhood that a user would have selected. So if I open up the parameters in this guy, you can see we're matching where neighborhood name, and that comes from the data set, matches the neighborhood name set from a published parameter. So we've got a published parameter in here called neighborhood. I'm going to edit definition to look at it. You can see it's just a choice type parameter with a list of all the different neighborhood names from the city. So we're using a tester to check where the neighborhood name from the dataset matches the neighborhood name selected by the user. We're using a reprojector here because the datasets are in different coordinate systems. And then we're sending this to a clipper. So we're taking our raster data, and then we're going to clip it to the boundary of the neighborhood that we've brought in, and then we're going to write out to our output. So we'll end up with output in the shape of the neighborhood that was selected inside the workspace. So let's publish this up to server and take a look at that. So we'll say File, Publish to FME Server. We'll go through the usual steps. Again, make sure you're uploading your data files. You'll see it's 42 now because we have the additional KML file that we're working with. Data download service should be selected. And let's publish that. And I'll just use the shortcut from my translation log here to open that up. And there we go. So we've got a whole bunch of different published parameters in here. So for raster tiles to read, we can leave that empty. Vector rows to overlay, let's select all of them, why not? Then we'll make choices about everything else, the coordinate system, whichever one you want. Output format, I'd go with PNG or JPEG just so you can look at it. Resolution, definitely go with a lower value. Compression level, doesn't matter that much. That'll only matter to JPEG, so if you select a JPEG, that will matter a bit. And then finally, we can choose the neighborhood. So if we don't select anything, it'll just read in all of the neighborhoods. So let's select any one of these. So I'll choose downtown for mine and click on Run. There we go. We should have one feature written. I can download that and see my output. And you should have something that looks kind of like this. Have a funny shaped downtown polygon, but that looks good. So I've got my data clipped to the area that I selected for my output. I'll do another quick show of hands here. Did everyone successfully download something clipped to one of the neighborhoods? Awesome, looks good. Okay, so looking at the time, we've only got a few more minutes, so we'll definitely wrap up this chapter before we finish for the day. So that brought us to the end of exercise 3.6. So you can see our output looks something like this for the city of downtown, or for the area of downtown. Let's do a quick module recap here. So for this chapter, we had a look at a few of the different services in FME Server. So we looked at the data download service, the data streaming service, and we discussed the Kml Network Link service. We've also now gained the ability to create and use published parameters within our workspaces. We tried out a few different types, looking at publishing the output format as well as the coordinate system and layers. And then we saw some different ways of being able to give an end user control over an area of interest. So that brings us to the end of chapter 3. There are some Q&A questions if you want to try those out. Definitely worth a try if you want to double check your knowledge and make sure you're understanding everything here. So with 3 minutes left, I don't think I'm going to even try to start the next chapter, but I will introduce it. So the next chapter, we're going to be looking at real-time with FME Server. So we're going to be able to set up a system that can react to events in real time. So in our case, we're going to be looking at first how to use automations, which is new in FME Server 2019, to set up FME Server to monitor a directory so that anytime new files are added to that directory, we can automatically run a workspace in response to that and process the data. And then next, we're going to look at setting up a system that can do something similar, but listen to emails being sent to FME Server and automatically process data that comes in through that. So definitely something to look forward to there. You may see there are 2 more chapters after this. They're not as important, I think, as this automations chapter, so we'll be focusing mostly on that. We will briefly take a look at message streaming tomorrow. Maybe I'll just do a quick show of hands. Is anyone here interested in message streaming? So this is dealing with high volumes of messages coming from something like a sensor or a GPS tracker. Okay, so we got a couple of hands. So yeah, we'll make sure to cover that. The exercise is pretty short, so we'll be able to do that. Chapter 6 is some advanced workflows, which are not as important. So it mostly actually goes into automations again. So we'll be discussing most of the concepts in chapter 6 in chapter 4. So tomorrow we'll be covering chapters 4 and 5. So we'll look at how automations work and how to build some simple ones.